In the previous example, we had represented the graph and how we can do the graph for any function. And we said we have a linear function, which is represented in a line graph. We have quadratic function. It's represented in a curve. And we have a cubic function, which I will show you right now while we're working, how it looks like. In all the aspects, we have to make sure first that this is a function before we describe this function. So as example, we have to make sure, is it passing, if I have a vertical line, will it pass with 1 point only or more than 1 point? If it intersects the function in 1 point and 1 point only, that means this is a function. But if it cut it in more than 1 point, this is not a function. We graphed this already. We did the graph of this. And here we got it. We did it on the board right now. And here is idea for exponent. This is radical. Radical because it's under the root. So the same idea also. We'll do the same. We'll do points for x, 1, 2, 5, 10. But wait a minute. We can't put x less than 1. We cannot put x for minus. We cannot put x for minus. We can put x for, and we cannot put x as well for 0. Why? Because if I say 0 minus 1 under the root, unidentified. Why? Because there is no root, no negative for a root. So again, I will say, I can say that x is a value here. As example, I will just show you what I'm talking about, but I will show you on the board. Like usually, when we show on the board, it's more clear to our dear students. In this example, I will stop the share and I will go back to the board and do it is, the board is, I think here it will be shown up. If I say root of x minus 1 under the root, let's assume that I will put this is with 0. So x here, if it equals 0, then I would say root 0 minus 1, that will give me the root square of minus 1, which is unidentified. So no value like this, I cannot put it. But if I put x starting from 1, if I suppose now that x will start from 1, so we said 0, no, because under the root, it will be negative, and we don't want negative under the root. If I put x with 0, it will be negative under the root. So if it is 0, when x equal 0, then this will be the root of 0 minus 1 will be the root of minus 1, which is not accepted. But I can do x equals 1 or more. So if I say now that this is the root of x minus 1, yes, I can start from 1. 0, no. 0 is not accepted. So then I would say the root of, suppose that x will equal 1, 1 minus 1 will equal the root of 0. That's fine, because the root of 0 is 0. That's fine. That's okay. Okay, so that means that x greater than or equal more than 1. Greater than and equal more than 1. Let's see here. I cannot put it in 0 like I said, but I can put it 1 or more than 1. And that's what we did right now. We'll go to share the screen back to show you why especially we said here, look at this now. We said that the domain, which x is belonging to all the real numbers, but x is greater or equal, at least equal 1. What about y? Why? It goes for all the numbers. But y is greater than 3. That's true. That's true. Why? Because if this is 0, then y will start from 3. If this equal, if x here was 1, then y should start from 3. If x from 1, then y should start from 3. Because it's not acceptable then the y will start less than 3. Because this is the minimum number for me, that x here will equal 1. In that case, y will equal 3, because 1 minus 1 will be 0. The root of 0 is 0 plus 3, so y will equal 3. So in that case also, I have another condition, that range of y is belong to all the real numbers, but with a condition that y greater than or equal 3. So I have here y greater than equal 3. This is y for 3. This is the way it is. Here it is. Let me enlarge. Here we can go. And you can see now that x is greater than 1. Here is x. So when I go here, I start the x from here. I didn't start from 0 and 0. I start from here, which is 1 or greater than 1. This is the x, because x goes horizontal. X goes horizontal. And the positive, and y is greater than 3. So I have to go the high for 3, because this is it. So y starting from 3 and x starting, y is the 3. The 3 is vertical, guys, like this. The y is vertical. So y starting from 3 and x starting from 1. I think it's very clear now for you guys that how to get the domain and how to get the range for this example. Okay, we have vertex here, we don't have vertex here. And when we graph it, it will take this line like this way. Okay, this we call it radical. Why radical function? Why we call it radical function? Very easy, because there is a root here. As long as there is root, then this is radical function. As long we know now how to decide the domain and how to decide the range. The domain might be conditioned or unconditioned. Conditioned when I say, yes, x belong to all real numbers, like here, x belong to all real numbers. But with a condition, this line like this, vertical line, means with a condition that x is greater than 1. And when I come to see here, x goes horizontal like this. X goes horizontal. Yes, x does not start from here, from the 0 point. No, x starts from 1. This is 1 point. Here it is. 1 point. X starts from 1. Y, as long as x started from 1, y will start from 3. This is logically. It cannot be, by other meaning, y cannot be less than 3. Y is greater or equal 3 means equal 3 or more than 3. Why that is? Why we did this? Because when you see y, this is 2, 3 points. Go vertical for the y and go horizontal for the x. X is horizontal. Y is vertical. So you go to y, you will leave 1, 2, 3. Here it is. So you start y from 3. And this is the range. We have the domain, like we said, the domain for the x and y for the range. Domain x, range y. This is a point. And this function, we call it a radical function. Why the word radical? Because there is root square. There is root square. But before this, we had a function called quadratic or quadratic. Quadratic because it is the power. Here is a square. Actually, the power should be for x. But here, if we just simplify this number, then this will be x squared minus 2x plus 1. So x will be squared here. So as long as x has a power of 2, we call it quadratic function. And usually it takes a figure of curve in most of the cases, and there might be a symmetry as well, like what we would see later on. Okay, we'll go to our next point. Here, I have to decide the domain and the range, but this is not a function, guys. This is not a function. The reason why it's not a function, like I told you before, let me show you. Let me show you. Why this is not a function? Why this is not a function? I will tell you why. Like you see here, this is a circle. If I come to make a line, to drop a line, let me see here, take this point. From here, I will take this line like this, and I will go any place, anywhere you wish, and just go vertical that way with the line. You guys can see the line? Here it is. Then it cut the function in 2 points. It did not cut it in 1 point only. It cut it in 2 points. As long as it cut it in 2 points, this line make intercept or make intersection with 2 points. Here is a point and here is another point. In that case, this is not a function, but still has a domain and has a range. Still has a domain and has range, like I will show you right now. So we'll go to the domain and the range. You can see here now, when we graph it, it takes this figure. So it goes from x here is from -6. This is -6. This is the x. The x-axis is always on the, let me just take a pen from here. So the x-axis goes like this, vertical, horizontal, like this way. This is the x-axis. So x started here from -6 and goes all the way up till 6. That's it. So the domain or x from x lie in between -6 and 6. What about the y? The range of the y is the same, because if you see the range of the y is vertical. Here, the y is vertical. So if you look at this, the y here, y also belong to the real numbers, but y here also lies in between -6 and +6 as well. Lie between -6 and +6. Okay. Y divided by 1 divided by x plus 3. Can you imagine that x will be -3? I'm just asking you. We want to determine now where is the domain, and what is the range for this. The domain is x. The domain, like we said, and the range is y. Okay. So if I say like this, I just want to show you something. Of course, graphing it, we will graph it, no problem about this. But the point is, how can I decide the point of the domain and the range for this function? How can I decide the domain and the range for this function? If I say this is the y, I will stop y will equal 1 divided by x plus 3. Cool, guys. Let us go now. Here, like you see, the x is real number, but cannot be -3. And the y can be real numbers, but y never get to be 0. Never get to be 0. Yes, I will show you why. Why never get to be 0? Because y is far from the 0. Y here is far from the 0 point. It never get to be 0. You can see here. This we call it asymptote. Asymptote is a line that go parallel very close by to the y-axis here and to the x-axis here, but does not intersect with it. There is a small narrow space in between the red line and the blue line. We call this asymptote. Asymptote, like this way. Okay. Now go back and see. This we call it rational function. Rational means have nomination and have denomination. Have, this is denomination 1, and the denomination is x plus 3. But why we have the x and y that way? Okay. Let us see. I will just stop share and go to the board and see why x. Let's say we said we have the domain. We said like this. We said that the domain x belong to real numbers, but with one condition. With one condition, this is a condition, that x must be greater than, not equal, greater than, or does not equal minus 3. Y does not equal minus 3. Like you see here, y does not equal minus 3. Assume with me now that I did like this. Y, I will put x will equal minus 3. Y will equal 1 divided by, let's say that I put x equals minus 3. Then minus 3 plus 3, that will equal 0. Then y will equal 1 divided by 0. I know from the math that if I divide a number, any number, by 0, that will give me infinite. That will give me something is called infinite, which means no solution. 1 divided by 0. For that reason, x will never equal minus 3. So my condition here for the domain, x belong to real numbers, with a condition that x will never equal minus 3. I showed you, because if it become minus 3, I will divide 1 by minus 3. That plus 3 means 1 divided by 0 will give me infinite. For sure. Okay, we'll go now to the range. The range here, y will never equal 0. Y will never equal 0, because simply here I have a number. If this was 0, then I can say y will equal 0. But y here cannot equal 0 because we have a number in the nomination. So how y will be 0? To get y equal 0, that means this number will be 0. So 0 divided by a number will give me 0. For that reason, we say that the range here, we'll say that now y belong to real numbers with a condition that y do not equal 0. Y do not equal 0. And that is how to put the domain and the range for this example. How to put the domain and range for this example. I will just stop, go back for the share, and we'll go to the example which we were working on. Here it is. The domain is x will belong to R, and x does not equal minus 3, because if it equal minus 3, that will be 1 divided by 0, then will be definite, indefinite, or infinite, or there is no solution. And that's impossible. And also, for the range, y will belong to all real numbers, like here, y will belong to all real numbers, like here, but y never equal the 0. And by the way, guys, you cannot see here y equals 0 because nothing is intercepting with the y. These two red curves do not intersect or cut the y-axis. They are called asymptote. Asymptote means there is no touching. They just go close by, but they don't intersect with the y-axis. Horizontal asymptote at y equals 0, and vertical asymptote at x equal minus 3. So this is, we call it the rational function. Like I said, we have nomination and we have denomination. Thank you.